Today I have Sashanka Vishnuvajhala. He is the SVP Eng at Fanatics Engineering. If AI can really code fast, why would the engineering teams not run insanely fast? And that's when I looked at the problem statements, there are aspects that are slowing them down. He saw the problem, he clinically analyzed the problem, then he has a solution and he saw the results. His org has 300-inch members, and if you consider the impact here, this is 300x impact is what we are essentially talking about. I'm Suresh Mathew, and this is One Idea. Welcome, Shashank, to the show.
Thanks, Suresh.
Before we dive in, quick request. If you like what you see, if you want me to bring people like Shashank more to the episodes, please like or subscribe to our channel. Shashank, before we dive deep in, right, give us an idea of what you do, how many people are we talking about, what is the scale of everything?
Fanatics is the world's largest licensed sports commerce platform. It manages websites like NFL Shop, MLB Shop, NHL Shop, WWE, PSG. We're talking about millions of fans all around the world celebrating their wins by buying merchandise on our websites. We boast about 3 nines of availability. We are an AWS shop. We have 300 engineers. We have 800 plus experiments running on our platform day in and day out, trying to optimize for customer experience. This does not actually talk about the size is not the thing. The difference between a regular commerce platform versus Fanatics is a sports angle, right? Most e-commerce platforms have like a gentle ramp. I would actually say in amount of traffic, orders, and maybe the occasional Black Friday ramp when it takes hours for the ramp. But in sports, it's completely different because right after the Super Bowl is done and your team wins, you want the merchandise right away in seconds. It's no longer a ramp, it's a slam, right? So your platform has to handle this load, otherwise you miss that moment, right? So the inventory is not infinite, right? The timing is really important, and if the platform does not perform, that fans euphoria is is either happy with the result or otherwise it's a stacked race. So we take customer experience and the fan experience, we call it very, very, very highly, right? Very, very seriously. And we want to make sure that the fans have the best Super Bowl championship memory in their lives. So the whole work that I'm going to talk about today is like you got to think about we are making changes at that scale, ensuring that that performance still is up there. 3 nines, 4 nines availability is up there, site speed is still there, fewer bugs, all of these things combined. So basically, we are making changes to a complex ecosystem, is the takeaway here.
Now, let's talk about the pre-2023 times, right? GitHub Copilot times, when you could probably get some things done. You have an order complete, as you call it, right? What was not working then? It was still an improvement from what you were before, what we were doing before. What was not working? What was working well?
Autocomplete is what I still call it. Copilot was great. Engineers loved it. In all their surveys, people were like, oh, we are making more progress thanks to Copilot. We enabled it for all of our engineers, but the numbers didn't change. Productivity did not actually improve. The throughput did not improve because it highlighted that faster typing was never the problem, right? Writing code was never the problem. Writing code is probably the least amount of time our engineers spend on. It's everything around it that made software engineering so much more complex. The design reviews, the code reviews, the working with the PM to understand the problem more, working with QA to think about acceptance criteria, talking with the other senior engineer in getting guidance, right? Improving what they are doing. So the art of software engineering, the actually producing of code itself, from other vantage points, it might look like that is the thing that is actually taking the longest, but it was never the case. So Copilot kind of resurfaced that to me, that realization, and that's probably why the productivity was not actually seen from the
The
business point
satellite
of view.
areas were not working.
That's correct.
The
That
core
is
was improved.
that's correct.
Writing code was improved.
That's
Okay.
correct. So the Copilot was AI running in the IDE. It did not have context of the entire system to be able to actually make improvements in productivity in the whole landscape.
Now, that part is clear to me. So it is helping you write the code. Anything around it will still have almost zero impact, or at least close to zero impact. Now, 2023 or late 2023 or early 2024, that's when this sea change happened, right? A step function. Now that's a step change. Tell us more about it when you started seeing the real AI agents not just helping you write code, it is almost writing code and asking you for, can you take a quick glance at it, right? The ask is very different.
I would actually frame 2024 as the progression, right? Like it was going from that autocomplete mode into more complex tasks. It was so much better in writing better unit tests, for example, things that were not actually hitting the customer, but making front end changes, making improvements in service contracts. It was not there yet, especially in brownfield. But in Greenfield, it was excellent. Building prototypes was excellent. You would hear all these videos on YouTube about people accomplishing amazing things, and you would be amazed. But you could not take that back into a production ecosystem and build at scale for something that impacts millions of customers. So it was still, we were trying and trying, but it was not there all of 2025.
Can you name the tools that we are talking about also here?
Absolutely. We used all of them, right? We used Cursor, we used Copilot, like we talked about earlier. We did not have access to Cloud Code at that time. We just got it access in 2026, and it was a life changer. But we used all of them in bits and pieces. We could not roll it out to the entire organization because we were also figuring it out. And we will talk about decisions in a minute. Late 2025, I think around Sonnet 4.6, and when we had like anti-gravity from Gemini, the CLI came along, it was not a small step change. It was an exponential change. It was a materially improved models. During December, I very clearly remember I gave it a large prompt to redo the Fanatics header. My prompting was poor. I actually wrote about it somewhere about how I could not structure the prompt in such a way where I give it a very large problem. I was not very impressed with the results. Then I learned how to structure the problem, how to write specs, and how to actually decompose the problem and give it to the AI. And I was blown away out of the results. So coming back from the vacation, going into the office, I made a pledge for myself that this is going to actually be really, really be impactful going into 2026. So worked with our leadership to get and graciously allowed the leadership to get all of these technologies into our ecosystem. And that was the start of a huge journey and milestone at Fanatics.
In this process, right, you had an AI agent in play and you were writing code and you saw the results. What was the first thing that you thought you could solve with this?
Thank you for that question. So I also need to emphasize that just coding would not suffice. When you ask me to name other things, we also introduced Glean into our ecosystem. We also had enterprise ChatGPT for lookups, and now we also have Claude in the office as
I
well.
don't have to ask what is your favorite. I know what's your favorite.
I have to say the context and the information lookup is what makes engineering so much better. You do not need to ask the same questions to 10 different people and piece together that information, and that information may not be 100% accurate, right? Because there is legacy, there is historical, things might have changed. If people's information could be stale, but never with a system like Lean or with Cloud. You are able to get the latest and the greatest, and the lineage is preserved. So that also makes engineers so much better.
What is the first aspect, right? So you saw that, yes, now I can not just autocomplete. I can probably take significant bulk of changes from your AI. You probably are now assisting the code check-ins.
Before that, I want to explain a couple of things, if you don't mind. So the number one thing was, come February, I was in my mind um, arguing with my engineers or debating with my bosses on what technologies to bring into Fanatics for enabling all my team members and making a case for it.
What were the main technologies in question?
Again, all the three I mentioned with Claude and Codex and Gemini. models, and making cases for how it actually will improve productivity and how it is going to be a completely transformational moment for us. And my leaders are extremely smart people, and we were having very healthy debates about what technologies to bring in. I needed to know how to use these tools myself before making proper guidances to my team. My bosses were happy to guide me and give me these technologies for my teams, absolutely. But to help motivate my teams, I needed to know how to use these tools, and I needed to be hands on. I picked a project that was bounded so that it can be measured. Pick something that is legacy so that I can be honest, and also the other tension metrics was it had to be real, that any mistakes I make can hurt.
Perfect. So you can validate now. It's a complex enough problem, and it's going to be a common problem too, because legacy systems migration is a common. Okay, awesome.
That's right. So I picked a project like that and put myself into hands-on development. I started coding myself. I also put some of my senior engineers on this concept called triad, where a PM, a developer, and a QE or a designer, depends upon the project, is working to build a large problem all by these three people.
Two things in parallel.
Multiple things in panel. These are two examples, one of which is my example. In 9 weeks, I wanted to immerse myself. I wanted to still do my current job of being a leader for the day job, but I also wanted to see how I could actually go get back into the back to the keyboard to learn a thing or two, so that I can guide my team members better. I can actually make better decisions on how to do things, how I can actually set up a framework for how developers can grow. So that was my intent. And yeah, that's how we picked the projects.
And the results?
The results were amazing. We rolled out that triad project into production within weeks. It took a couple of iterations. We still needed to learn about how to work with design, because at that time, if you remember, Claude design wasn't there. So design back and forth was a thing. But we rolled this project out, finished multiple rounds of A/B testing already on the site, and you would see this project go out very, very soon. It's the new header that I was talking about earlier. And two, my project was actually going and using a new design system, something that you and I worked on a long, long time ago at eBay, at V4 at eBay in way back when. And very similar to that, we were actually rolling out a brand new design system across our platform. And that was a 9 weeks project. It was close to 0% complete at the end of February, and it's almost 75% complete as I speak right now. And it required more than 30 plus PRs. Each PR review had, like, on an average, 14 to 15 turns back and forth. And we'll talk about how that works. And bugs, obviously, some serves and incidents that aside, right? That's not going to be free of all of that.
Yes.
And it required a lot of support from my teams, but we did this really, really fast, and some good numbers to share.
In fact, in my intro, I was thinking of those numbers as well. 4 engineers, 6 sprints to 1 engineer, 5 days. That's the scale that you're talking about.
That is exactly what I'm talking about. That number can be different per organization, per problem, how many repos you're touching, how many services you need to deploy, etc. This is a number tied to one repo, but with thousands of files updated, 88 surfaces touched in the complex ecosystem of Fanatics. And we were blown away by that number.
And this is not a greenfield project. That's the best part, right? So this is probably applicable to 90% of the viewers. Nobody has a hello world project to try AI on. These are the real world examples. Awesome.
These numbers generalize, right? This is actually for every mature platform out there which has to roll out code while also doing business, while running a business and ensuring the customer experience is not impacted. Y- This generalizes.
Perfect. Now let's go back to the pipeline. Now you had to fix the coding, and coding, of course, is one part of it. Tell me more about the pipeline aspect of it. What exactly had to change there?
One thing that really blew my mind away was, even before the code assist days we were talking about, we had a very, very high standard for code reviews. Everything had to be reviewed by multiple people. We had like style guides. We were enforcing coverage numbers. We had all of those great and usual software development lifecycle guidelines and guardrails. But code review was always a choking point. It was a real bottleneck for us because a lot of bias goes into code reviews, right? Like we consider ourselves the best code reviewers, like we judge other people's code, sometimes most of the time with good intentions. Sometimes you have preconceived
There's
notions
a lot of
about that
emotion
time,
in
right?
play. I get it.
Absolutely. There is a lot of back and forth. And also, you probably don't want to argue that much as well. Maybe you argue about something a couple of times. After that, you give up. Assuming that humans are the best code reviewers is arrogant. And if you bring humility into the game, what would we do? Was the question I asked myself because this was becoming even bigger problem with AI generating most of the code. An engineer could produce, let's say, 80 lines of code that is going to send a PR out in like a couple of days. Now that is like a 5-minute work for AI and it'll produce 1,000 lines of code and produces a lot. It was kind of arrogant to think that humans can actually review each piece of code. Humans are still responsible for judging having guiding the AI, and they're still accountable in this ecosystem, but they cannot be reviewing each line of code. So when I took that question to myself, what I came up with is, can I actually have AI, a different model, review the output of a different model? So there were PRs that we opened that was reviewed by 3 different models, and it had 14 to 15 turns about a different AI has a comment about something, a different AI responds with a solution, sometimes fixing it, sometimes debating it. And each of these models had different prompts, right? We could even review some of the PRs with like an infosec angle from a front-end engineer angle. At Google, we used to call them readability reviews and code reviews. Here, you could actually change that system into have like multiple varieties of prompts and multiple models reviewing the same piece of code. So what happened was, even with all this back and forth, you could actually get these PRs at a very, 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 very high quality level, expensive but very, very high quality level. And we had so much more confidence that when the human was actually reviewing it at the end, he or she was much more comfortable in approving or moving forward with part.
So, but the review still happens. The developer has to still read all the code, or
Most of the developers check all the comments and all the code that was done. They look at the structure, they look at a very well written PR description and approve. Right? They're not reviewing every line of code. It's impossible. Again, that's the arrogance and I'm talking about, and we have to bring humility into this situation.
so that is where I'm still finding it not easy to really let something into production without a pair of eyes on it, right? I'm sure you get to a point where the agents will fix most of these issues and there'll be an agent in production too, but still not comfortable yet to push something into production without like touching it.
Completely fair. And I talked about it in my blog as well about where 100% of the code is generated, but 0% is autonomous. As in, at every step of the way, you as a human are actually reviewing the output at that stage, right? Because while you're actually coding as a developer, you're ensuring that the agent is doing what you asked it. And that's where a well defined spec comes into the picture, where something that software engineers wanted to do forever with test first development but never did can actually be done right now. This is the extreme programming concepts we learned in school 2000 whenever. And you have this setup where you can actually do test first development and ensure that the agents are doing what you're asking at every step of the way. So the output you will be judging. This is the part where you're judging, you're guiding throughout the development, and it goes to review. I actually think if the PR is 250 lines long and touch several thousands of lines of code, previously you would not have even attempted that PR out of fear. So suddenly you are doing things that you were scared about. So AI has actually suddenly given you this courage and makes you fearless. And again, it's always our trust in humans that we can actually review all this code. So at some point, we will give it away. I can understand your fear, and I think it's a very rational fear, but we will get to that place.
No, I'm 100% with you. So this is by the way, this podcast is never about us. But in this case, I'm running an autonomous company, right? So there's a Sedai is an autonomous engine that trusts on its AI to make decisions, and we don't have in fact humans in this flow. Right? The whole thing from figuring out what's happening to like executing in production, the model is doing it with confidence. But that model is very different from a large model, right? So that's why I was asking this question, saying on a large language model, the biggest problem I see is there is by design, right? You are supposed to give wrong answers. And wrong answers, tolerance is almost zero when it comes to production. Okay, perfect.
And we already talked about this. We did have bugs. We did have incidents. So there is definitely that where you will, and this is a curve, right? You are as a team and as an organization are going to evolve. We are not there yet where we have zero humans, but I think it will get there.
Now about the handoff. This is the most interesting part in my mind. So right now we figured out the core system changing. Now you have the downstream that's now ready. Now the upstream, like the product managers, the requirement to the product manager, to the developer, to the QA, right? All these handoffs. I've heard from you that it is very different in AI world. How different? Please explain.
Yeah. This is a completely evolving space, and my thoughts and opinions have been evolving as well. So, with that caveat, let me explain. We all must have seen this traditional software engineering cartoon about what the customer wanted and what they eventually got. This is a traditional one. You can just look it up about what the customer actually wanted a tire swing on a tree, but we have actually done all of this effort to because the a lot of context was lost in handoffs between the product manager from the business to the product manager to the designer to QA and developer, and eventually there is a lot of drift in this context. So my belief is that we are going to be producing a very well defined spec. I'm calling it the intent spec. There are many people in the industry calling it the intent spec as well. Intent spec covers structured information about what is that the business and the PM wants to accomplish. MD file, and that MD file is no longer living somewhere else in your with your ticketing system, but is actually referenced by the ticketing system. But that artifact lives with code. It evolves with code.
In the same repo.
That's correct. That's correct.
Is there a structure of the folder or anything like that?
We can actually talk more about the
No,
detailed
I just
structure
want
about
to
it.
know that. Okay.
Another important aspect of software engineering is a lot of discussions happen after a ticket is created with the requirements. And those discussions become requirements but are never put back into the original ticket. So when the developers are done and hand it off to QE has no reference to what those decisions were. So we will have to keep that intent spec and the requirement spec are very intact. The PRD is not like this gigantic document anymore, but it's actually like a single page, but it's tied to the intent spec, and then there is a tech spec. So we can talk a lot about the SDLC itself, but the artifacts completely change. The artifacts are live, evolving documents with code, just like the code evolves. And imagine how much better Enterprise ChatGPT or your Glean would be because they can actually give much better responses when you're asking about a question about something that has implemented something that was implemented a long time ago. And because the intent specs live with code, you also have the benefit of lineage and also have history, the versioning. All of that comes for free. So this is an evolving thought process for me. Maybe I'll come back and we'll discuss these artifacts at some other time.
Maybe once we figure out a framework there, this handoff and handshakes, I think it'll be very useful for all of us. And it's an evolving space, and everybody is trying to figure this out, including you and me.
And the roles are changing. I'll just speak about roles a little bit about the QE being still being responsible for coming up with the acceptance criteria based upon the intent spec has not changed. That they still do that, but the acceptance criteria are also spec and then live with the code. And that spec can be automatically be taken by an agent to produce the automation and the unit test. So it's an evolving space and evolving thinking among leaders on how to improve the SDLC accordingly.
Now about the numbers, this is where I think these are unbelievable numbers, right? So one thing I heard is let's talk first about your solo experiment and the 90 engineer experiment, both, right? So let's share with us the numbers on both. And what were you expecting when you started, right? What was your expectation and were you like surprised, shocked in a good way?
Like I said, we were 0% done at end of February. We had tens and tens of PRs and code reviews done. Remember, we cannot make a lot of visual changes with A/B testing. We talked about A/B testing earlier. So a lot of these things were A/B tested while I was developing other components. Like for example, if we updated text fields were being A/B tested while I was working on models, things like that. But within 9 weeks, we were able to actually get from 0% to 75% done. Each PR was reviewed, like I described earlier, with multiple rounds. And we had multiple QA available. We had 5 or 6 SEVs, things that happen in production when we had to do a hot fix, painful. But admittedly, I picked a project that would hurt if I'm making mistakes. And
That probably is the right way to validate.
I have to have scars to go back to the
Hello
tool.
world cannot validate anything.
That's exactly right. But I kept reminding myself and my team that a single person's story or a single person's success is not the point. The point is, how do we actually enable the entire team to up level? So this point I have been stressing, and my leadership has been stressing on this point as well. The point is not getting our best performers do even better. They will automatically do it. Right? It's meaningless to try to get them to do better. They will actually teach us how to do things. I think it's about how to get the median higher, right? How do we actually make our median like so much better with these tools? And that was my focus. And that's how we want to think about it. So we had executed something we call an AI day. We had 90 engineers pick things in the product, in the backlog of some of the things we anyways wanted to do. We picked those instead of like a traditional hackathon where you build anything your heart desires. We wanted to pick something in the product backlog. Things that were scoped for weeks or sprints, and we kind of pushed back because it was a lot of effort with the kind of projects we picked on that day. 33 submissions. We picked the top 15, all 15 presented. And we took the winners out for an IPL match between SRH and PBKS in Hyderabad. And the outcome is multiple of these projects are already about to go to production. Things that took multiple sprints, as we saw people being able to do it in a day. It still showed cracks in our CI/CD deployment platforms where it would take a little longer to get these things out. We could not actually release in a day, for example. So something to invest in. But it really showcased the power of AI to the entire team. 77% of the people that participated, we had a pre and a post survey to measure the impact. 77% came out more confident, and the median numbers actually grew 4 points on how much they can actually produce as well. We had a structured 17 question survey, and the same 43 people participated in both the surveys. So we have like good statistical numbers to showcase that as well.
Perfect. Now about the dual engine. The industry talks about AI replacing people, people replacing AI all the time. You are talking about these two guys working together, right? So especially having an engineer and AI counterpart coming together to finish stuff up. So now for people who are hesitant in really taking that step, what is your, for an engineer at Fanatics who's a little hesitant to take that step, what is your angle?
You are not competing with the model. You are being partnered with the model. You are supposed to be the judge. You are supposed to be the guide. You are supposed to be accountable for everything that you are doing. If you are partnered with a junior engineer, you would take the same responsibility. This is just a junior engineer who can actually do things much faster, will never sleep, and would never actually complain, right? That's how I would want my senior engineers to think. And from a CFO angle, this is no longer a tax line. Software engineering should not be considered a tax line. It should be considered a margin line, because the gains that we are actually seeing, what I have seen senior engineers do is take that time they are actually saving while producing these large, meaningful projects and PRs out for out into production. What they're using their time is fixing large security issues. What this AI revolution is going to show us is the pipelines are still the same, right? We talked about pipelines earlier. Just the flow is going to be a lot more. So every bad weld will be exposed. So you will have to take care of these pipelines, and you will have to take care of all of these bugs that were lying around, all of these backlogs that we were not able to achieve. We can actually achieve that much sooner. So I want to suggest that they take that a lesson from every hesitant engineer has to think about those things.
Now, for you, there's a special case here, right? You stay very close to the code, and generally leaders, at least when you get to a more VP or above, right, you start really focusing on the strategy and leaving the code, which I'm also a firm believer that you should not. You land in an initial category of people, right? So people generally are not into code, especially when they are a VP or an SVP. You are focused more on the strategy side, but you have been staying very close to the code. From what I know, you probably are the top percentage of contributors there, right? And there, of course, are two sets of people here, right? Especially our audience. There would be a set that is very close to the code, and there would absolutely be a set that is not. What is your advice to really get this experimentation and adoption going for those two? Let's start with the first one where you're close to the code.
I think staying close to code is vital during this AI revolution. I actually think that there has never been a tool that can like that you could delegate work to ever that is as good as AI, right? But that actually makes it even more vital to remember that you cannot delegate the understanding. So being close to code gives you that power. I cannot, in good conscience, go and push people or suggest things that based upon a YouTube video or a blog post, right? Those videos are either coming from companies that are in the explore phase, where the complex, it's greenfield and it's small and they are able to achieve things, or it's an example like a hello world example you were talking about, or they're coming from companies that are in the extract phase, where they have very large budgets and very a large ecosystem, and they're still making changes in one small vertical or a surface area. So I actually think that this is the time for people to spend a lot more time hands-on, especially the leadership. And I'm talking to the VPs and SVPs and CTOs and my peers out there, where they have to be hands-on to get there. I go back and write about this in my blog as well, about like an example of an ancient India, right? Where you had like this master craftsman that you would actually go and carve things out. The leader of the bunch was a master craftsman. He would actually go train kids on how to craft these things, and he was a master craftsman. Slowly, because of the industrial revolution, managers and the craftsmen have actually kind of separated, right? Like we no longer, we are actually encouraged heavily to not be the roadblock, not be the bottleneck, not be hands-on, because you're going to block everything, slow everything down, which is always what do you call, I would not say it was wrong, it was actually really right in many circumstances. But AI kind of brings it back into this master craftsman mode, where a leader has to be a master craftsman to lead his team, and you have to be hands-on.
Okay, so then the second group, the suggestion is very simple: be in the first group and then do it, right? So the second group is not familiar with the code. Just get familiarized with the code. Just experiment it first before you execute. Okay, got it. Now, McKinsey's data shows that 93% of the people who are investing in AI are not really getting results. 5.5 is the number that is getting results. And you are absolutely on the 5.5. Now, how do we get the 93 to zero? And everybody is now benefiting.
I think this is, again, how you adopt AI. If you start thinking of AI as just a productivity layer, you are going to not see that improvement. If you are too scared of adopting AI and use AI for side projects, internal tools, you will see some impact, but you would not actually see the impact, this structural change that you have to make for AI. You cannot, you won't see it fast enough. You will see it eventually, but not fast enough. Second thing I would actually say is stop optimizing for which model is better than the other. All models are great. There are, like, right now I love Codex more than Claude personally. I think the point is making your system and your context much more accessible to AI. uh, Ensuring that you are creating MCPs everywhere, ensuring that you are actually removing these bottlenecks for AI to get richer context. I think that is like a really, really important thing. Next is security as your partner, right? InfoSec teams have very, very, very good what do you call, opinions about how to enable certain things, stop certain things, block certain things, and you have to work with them because it's an evolving space for them. Even simple things like manage settings for Claude, there are so many things you could be doing that can help improve the productivity of your entire org, but it has to be done carefully and in partnership with the InfoSec team. Again, I'll reinforce, this is just isn't a velocity story. This is really a capital reallocation story. There is so much more to be done, and how to elevate the entire code base, improve the median, raise the bar. So that's how I would suggest.
Now we've completed that coding part, right? Now this is probably even out of scope for this podcast. But let me ask you this question. This came to me. Once you have code in production, now it's running. Do you plan to use AI to handle those issues that happen afterward? And like an AI SRE or an AI agent that could figure out what's going on and help these developers fix? It can tie back to the PR and things like that, or are you slowly getting there, or are you already there?
We are already there. So I would not say consistently across all of our surface area. There are definitely some teams that are ahead than others, and this is something that every organization will go through. We talked about incidents and SEVs before. We realized that our time to recovery on SEV 1s and SEV 2s has improved by 14% because we are able to realize and recognize where the issue is much faster. We still, like I pointed out, have issues with CI, CD, and approvals and the process of deployments and stuff like that. We still have opportunities to improve. But how fast we are able to get to what the problem was and getting into a solution is like much, much, much faster. And every second matters during those large incidents. So we are very excited about that.
So basically, we talked about how to experiment, how to start. And for leaders, maybe the first thing to do is to familiarize or go back to your coding time and at least make sure that you start the journey. Then we figured out where the pipeline is blocked, made sure that yes, that pipeline can be unblocked and we can get that velocity. The last part is now in production also. It is all AI enabled. Awesome. So thank you so much for spending time with us. This is an awesome story. And this is as I said, this is very close to the ground reality. And I'm sure the viewers would appreciate that a lot, right? So people have there are a lot of YouTube videos out there as to how to use AI everywhere, but there are not a lot of videos that or people that will share stories where they looked at a project that's running or was an older project and then used AI and that showed significant improvement. So thank you so much for sharing.
Absolutely. Thank you for having me.